Hello citizens of the world. In today's video we're gonna see what are agents in AI. In artificial intelligence, an agent is a computer program or system that is capable of performing intelligent actions in an environment to achieve a specific goal. An agent can be viewed as an entity that perceives its environment through sensors and takes actions based on its current state and the goals it is trying to achieve. The actions taken by an agent can affect the environment and can lead to new observations, which in turn can modify the agent's state and goals. There are different types of agents in AI. The first one is simple reflex agents, the second one is model-based reflex agents, the third one is goal-based agents, the fourth one is utility-based agents, and the fifth one is learning agents. Agents are a fundamental concept in AI, and they play a key role in many different AI applications, such as robotics, game playing, natural language processing. Now let's understand the mechanism of each agent. The first is simple reflex agent. This agent operates based on a set of predefined rules. It consists of four main components: a sensor to perceive the current state of the environment, a set of condition action rules, a rule interpreter, and an actuator to carry out the appropriate action. The agent's behavior is determined by the condition action rules, which map a particular input state to a specific output action. The rules are specified using an if-then format, where the if part specifies the conditions under which the rule applies, and the then part specifies the action to be taken. The main limitation of a simple reflex agent is that it only considers the current state of the environment and does not take into account any past or future states. It won't make the best decisions in complex environments. However, it can be useful in simple, where the agent's actions can be fully determined based on the current state. The second is model-based reflex agent. A model-based reflex agent is a type of agent that selects actions based on the current percept and the agent's internal model of the environment. This type of agent maintains an internal representation of the current state of the world, as well as a set of rules or a model that maps states to actions. When it receives a new percept, it uses the model to determine which action to take, based on the current state and the desired goal. One advantage of a model-based reflex agent is that it can take into account the long-term consequences of its actions, beyond just the immediate percept. However, this approach can also be computationally expensive, as the agent must maintain a model of the environment and perform calculations to determine the best action. The third one is a goal-based agent is a type of artificial intelligence agent that operates by selecting actions based on its current goal. In this approach, the agent is designed to achieve a specific objective or set of objectives, which it aims to accomplish by taking a sequence of actions in its environment. The goal-based agent has four main components. The first one is the current state of the environment. The second one is the set of possible actions the agent can take. The third one is the set of rules how the agent should choose the next action based on the current state and its goal. The last one is the agent's current goal or set of goals. The agent's objective or goal is typically specified in advance by a human designer, who defines the desired outcome that the agent is expected to achieve. Goal-based agents are commonly used in a variety of applications, including robotics, game playing, and decision support systems. The fourth one is a utility-based agent is an agent that makes decisions based on maximizing a numerical utility function. The utility function assigns a numerical value to each possible outcome of an action, reflecting the desirability of that outcome. The agent then chooses the action that has the highest expected utility, based on its beliefs about the world and the outcomes that may result from its actions. Utility-based agents are often used in decision-making problems where there are multiple options and trade-offs between different outcomes. For example, in a robot navigation problem, the agent may need to decide which path to take to reach a goal, while minimizing the risk of collisions or damage to the robot. The utility function would assign a high value to reaching the goal and low values to collisions and damage, and the agent would choose the path that maximizes its expected utility. The last one is a learning agent is an agent that can improve its performance over time by learning from experience. Learning agents can adapt to changing environments and improve their decision-making capabilities without human intervention. There are different types of learning agents. The first one is reinforcement learning agents. These agents learn by receiving feedback in the form of rewards or penalties for their actions. They aim to maximize their rewards by selecting the actions that lead to the best outcomes. The second one is supervised learning agents. These agents learn from labeled data, which provides examples of correct actions or decisions. They use these examples to build a model that can make predictions or classifications for new inputs. The third one is unsupervised learning agents. These agents learn from unlabeled data without any pre-existing knowledge of the correct outputs. They aim to find patterns and structure in data.